This is Mrs. Palmer-Quay with the third video for Module 2. In this video I want to talk about how we measure heat and a particular characteristic of substances known as specific heat. Remember, energy can be defined as the ability to do work or to cause motion. Also, energy is something that cannot be created or destroyed, but it can change forms as it comes in many forms around us. Chemical energy, electrical energy, nuclear energy, we have sound energy, light energy. Energy is just found in many different forms. Heat is a particular kind of energy that moves from one object to another because of a temperature difference. The internal heat, the thermal energy found in a substance, cannot really be measured, but when it moves, then we can measure it. And temperature, remember, is a measurement really of the average kinetic energy of the molecules in a substance. So heat is measured as calories or joules as it moves from one object to another. And you know that heat will always move from a higher temperature to a low temperature. The flow always goes from high to low. A calorie, a substance we think about more in relationship with food, is actually defined as the amount of heat needed to raise 1 gram of water 1 degree Celsius. The calories that we measure in food are actually kilocalories. They're calories with a capital C. And so you can see that a calorie actually is a very small amount because we're just taking a tiny bit of water, just 1 gram, 1 milliliter of water, and increasing its temperature by 1 degree Celsius. More typically, when we're talking about chemical reactions, when we measure heat changes, we measure them in joules. That's the standard unit for measuring heat change. And a conversion that you should get very familiar with is that 1 calorie is equal to 4.184 joules. You already know that substances heat up at different rates. A metal spoon in a hot pot will quickly become too hot to touch, but a wooden spoon will stay warm even if it's stirring a boiling pot of soup. The amount of heat that is needed to raise the temperature of 1 gram of any substance by 1 degree Celsius is known as its specific heat. The specific heat is influenced by the phase that the substance is in. What phase of matter it is a solid or a liquid or a gas. And of course the chemical composition of different substances will have different specific heats. In general, a low specific heat means that there will be a fast change in the temperature. And so if you look at this table of specific heats, and we have our metals down here on the bottom, you see that there are very small numbers. Decimal points, not even a whole number. These are all low specific heats, and metals do change temperature very rapidly. As might be expected then, substances with a high specific heat experience a slow change in temperature. It takes lots of added heat to make this substance increase its temperature. At the top of this chart, you'll see we have liquid water, where the specific heat is equal to 4.18, we could put a 4 in here, joules per gram, which if you remember from a previous slide that the definition for a calorie was the amount of heat needed to change a gram of water, or 4.18 joules, 1 degree Celsius. So specific heat is just another variation on that definition. It's just referring to 1 gram of any substance, not specifically water. The high specific heat of water is what makes life possible. Imagine if we were robots all surrounded by metal, how quickly we would heat up in the hot sun. But we are about 2/3 to 3/4 water because our cells are a very watery environment. And so we can stand out in the sun and take a lot of that heat without really increasing much in temperature, and that allows us to keep living. There are calculations that we can do with specific heat because we can use it to predict temperature changes when heat is added. The specific heat equation says that Q is equal to Cm delta T. Q represents the heat that is added or released. When heat goes into a substance, it has a positive sign. When it is released, it has a negative sign, and we'll come back to that in a minute. C represents the actual specific heat number, and it's typically given in joules per gram degree Celsius. The mass, of course, would be typically in grams, and the change in temperature is calculated by taking your final temperature and subtracting from that the initial temperature. So if you get confused about which direction, which gets subtracted from the other, see we've got this alphabetical. F comes before I, so that you take your final temperature and subtract from it your initial temperature. So let's take some specific examples and use this specific heat equation. This first one says a 15.0 gram sample of cadmium metal absorbs 134 joules of heat as its temperature increases from 24 to 62.7 degrees Celsius. What is its specific heat? The basic specific heat equation needs to be rearranged so that we're solving for C, because we're wanting to see what is the specific heat. Too many C's in this sentence here. So if you just think about it, it's going to be the amount of heat change over the mass times the change in temperature. So we've just done some algebraic rearranging to isolate specific heat. So what do we know? Well, we know that the Q, the amount of heat absorbed, is 134 joules. And the mass is 15.0 grams. And then the temperature change. What's our temperature change? Well, we started out at the final temperature is 62.7. So we go for our final temperature, and we subtract from that our starting temperature, which is 24.0. So if we do the math on all of that, we'll find out that our temperature difference here is 38.7 degrees Celsius. And then it's just doing the math. If you go ahead and calculate out all of the numbers on this, we're going to get a value for C that is equal to 0.231 joules per gram degree Celsius. And as you see, this is a small number. It is just a tiny decimal, which is what you would expect from a metal. Metals have a low specific heat because they change temperature rapidly. It doesn't take much energy in to have a temperature rise. This problem asks us to use the specific heat formula to calculate a temperature change. It says, what is the final temperature of a 60-gram sample of water, initially at 23.52 degrees Celsius, that is cooled by the removal of 813 joules of heat? So we need to start with a specific heat equation again. So Q equals Cm delta T. Now I should mention that in your book it's written that Q equals Mc delta T. And since all of these variables on the right-hand side of the equation are multiplied, it doesn't really matter what order you put them in. Anyway, in this problem we're being asked to consider the final temperature, so we're wanting to know how the temperature has changed. So we rearrange the formula algebraically so that delta T is what we are solving for. So I'm sure you can see that this is going to be our Q divided by our specific heat and our mass. And then we start plugging in numbers. The heat change is 813 joules, but this has been removed from the water. And as I mentioned previously, that when heat is going into something, it is positive, and when it is coming out, it is negative. So in this case, we have to put a negative sign in front, indicating that the heat is coming out of the water. We multiply that times the specific heat and the mass. Well, the mass is pretty obvious. It's 60.0 grams. What's the specific heat for water? Well, I already told you that the definition of a calorie is the amount of heat it takes to raise 1 gram sample of water 1 degree, and that a calorie is equal to 4.184 joules. So hopefully you can see that the specific heat is going to be 4.184 joules per gram in degrees Celsius, because the definition for calorie and the definition for specific heat can sort of be slid into each other. And then we just go ahead and do the math. We're going to have units cancel out here so that we're left with temperature, or degree temperature, of negative 3.24 degrees Celsius. And this is equal to the change in temperature. It is the negatives indicating that the temperature has decreased, which we would expect since this is being cooled by removing heat. So if the initial temperature was 23.52 degrees Celsius and we have decreased it by 3.24 degrees Celsius, then our final temperature is going to be 20.28 degrees Celsius. So I hope that gives you a sense of how we can use the specific heat equation and what kind of questions you might be asked to calculate concerning this topic. And this finishes the third video for Module 2.